Okay, to solve this, the first step we're going to take, no matter how we decide to solve it, and we're going to solve it by switching to exponential form. We're going to solve it by estimating the graph. Okay? So 2 to the 3x minus 7 equals 9/5. Since we're in an exponential equation, we're going to have to be dealing with decimals anyhow. I'll suspend the whole requirement in this case of using the fractions, because we really kind of have to have the number to do the graph. Okay? So log base 2 of 1.8 equals, not 2 to the 3x minus 7, equals 3x minus 7. So that x equals 1/3 of log base 2, 1.8 plus 7. Now that's just a simple linear equation. Just added 7, then divided both sides by 3, and this is what I get. That's an exact solution. So you can do a calculator approximation. As I said last time, I want to see the calculator approximation after I see the exact solution. I don't want to see a calculator approximation here. Although if I do, I'm not going to get too excited about it this time. Okay? Probably cost you a point. Make sense? Okay. Now the other way to do it, very simple. Not a very good graph of y equals 2 to the x, but we'll pretend it is. Okay? Well, we know 2 to something has to equal 1.8, right? What's that something? We can find it from the graph. Come out here to 1.8. Actually, maybe about here. Now, of course, you do it with a careful graph. I just slopped one down because we're actually out of time, but we'll be done in a minute. Okay? So what do? We say, okay, well, there's 1.8. We project over here. I did get up too early this morning. That's no excuse. Okay. Take an extra 30 seconds. I know you're all sitting there looking at me like I lost my mind, but it's probably true. Okay, so here's your 2 to the x graph. We want to know 2 to what power equals 1.8, right? So where do we put 1.8? Not here, we put it up here. This is 1, so here's 1.8. We project over, we project down, and we say, okay, let's see, that looks like about 0.9. Okay? Now you do a good graph and you make that estimate. So we see that 2 to the 0.9 approximately equals 1.8, right? And we want 2 to the 3x minus 7 to equal 1.8. Well, it follows then that 3x minus 7 should approximately be equal to 0.9, since that's what we raised 2. That's the power to which we raised 2 in order to get 1.8, right? That makes sense? From the graph, we see what power of 2 gives us 1.8. Okay? That power has to be 3x minus 7. So we solve 3x minus 7 equals 0.9, and we get x equals 6.1 over 3, if I did that right, about 2.1 maybe. It actually rounds off to 2.0, but I hate to do 2.0. Okay? something's wrong. It's not a real good approximation, but that's how you do it. Okay? Make sense? When I check it back in the function, it gives me something much closer to 1 than 1.8.